Well, thank you, Dr. Vasquard. It's really a pleasure for me to be here today and to speak to this group. I want to thank Dr. Dillon for inviting me, and of course, Dr. Vasquard for picking me up at the airport yesterday. And I think you're very fortunate to have Dan as your compliance officer and heading your ethics component of your CTSI. Dan and I, as he intimated, go back many, many years. Dan has been involved intimately with the CITI program in leadership positions, such as on our executive advisory board. He's been, and he currently continues on now in his role as mentor and on our program advisory committee and mentoring especially our younger participants in the responsible conduct of research, and more importantly in the teaching of responsible conduct of research. So today I want to talk about research ethics education. It is indeed a value-added enterprise. So I'm going to talk about why integrity matters. I'm going to talk about research ethics education and the CITI program at the University of Miami. I'm not going to go into a lot of detail about this. Dan has really done a very good job in setting the groundwork. I will, however, show a couple of slides of data that has come as a result of our satisfaction survey at the end of the course, where we've asked the learners specific questions about their role in research and specifically the value that they see in research ethics education, or lack of value. I want to talk a little bit about misconduct and versus misbehavior. I'm going to talk a little bit about the cost of misconduct, both the financial cost as well as cost to our community. And I want to talk a little bit about non-reproducible science. It's getting a lot of play, a lot of traction right now, even from Dr. Collins at the NIH and others who are very concerned about how irreproducible results that could be the result of sloppy research practices, sloppy science, could be affecting the research record and how we move forward. And of course, what could we do about this? So I always like to start right at the very basics, and and I think it is worthwhile to just a definition. What is integrity, aside from this intriguing statue in Columbus? What is integrity? It is defined as a personal and steadfast commitment to a set of moral or ethical standards defined by your religion, by your community, or your professional discipline, or your professional society. Right? Another word for integrity is professionalism. Right? Professionalism. So why does integrity matter? Why does professionalism matter in biomedical research? Well, without integrity in research, the research becomes risky. Right? The research becomes risky. It's risky to the institution, it's risky to subjects, it's risky to society. The wasted resources, okay, makes it risky. Federal inquiry, audit, suspensions can be the result of lack of professionalism in research. Institutional embarrassment. How would it play in my instance? How would it play in the Miami Herald or in the Morgantown Gazette? I don't know the paper here, but personal embarrassment. Okay. Research without integrity can result in loss of funding, loss of livelihood, legal actions, fines, and in some cases, jail. But most importantly, the lack of integrity, the lack of professionalism in research, okay, undermines the public's trust. And so why is this important? Why is the public's trust even worth the effort? The public supports most of the research that's done here in the United States. Sponsored research is clearly a privilege and not an entitlement, as I've been told sometimes. The society trusts investigators to conduct their research ethically and with integrity. Importantly, the lack of public trust or violation of the public trust brings regulation. And none of us want more regulation than we already have. So to preserve the public's trust, there must be institutional and individual accountability. We must document our ethical behavior. The federal regulations specifically require documentation of ethical behavior. And so the federal regulatory requirements to document are designed not to satisfy the government's need for more paper, right? It's really in place to preserve the public's trust by reassuring integrity and professionalism in research. So integrity in research starts with institutional commitment to a culture of compliance. It's promoted and nurtured by the various regulatory committees, okay? The IRB, the IACUC, the Institutional Biosafety Committee, Conflict of Interest Committees, the Data Safety Monitoring Board, and the Office of Research Compliance. Should be embraced by all members of the faculty, investigators, staff, and students as just simply the right thing to do. So how do students, young investigators know what the right thing to do is? So it's all about being a professional scientist, right? Being a professional. This of course is a picture of Dr. Tabak. I never met him personally. I knew people that did meet him, and from those conversations and how they thought the world of Dr. Tabak. That's why I put his picture here as an exemplar of the professional science. So professionalism in science requires what? Honesty, conveying information truthfully and honoring commitments, reporting accuracy, reporting findings precisely, and with care to avoid errors. Objectivity, letting the facts speak for themselves and avoiding the temptation to hype the data. Right? Providing appropriate credit to others who have worked on the project and that have provided the background data or background papers to support your work. Compliance with all the regulatory requirements to document ethical behavior. Scientists, I guess what I'm trying to say is that scientists are not in the business of deception. So, but there are professions where deceit is the norm. You know? So often, deceit is just part of the mix. Oops, I'm sorry. So in sports, right? So the pitcher, it's not enough for the pitcher to throw a 95-mile-an-hour fastball. Okay, it has to be a split finger fastball that dives out of the strike zone to confuse the batter, right? So in sports, deception is a major part of the game, right? Entertainment. We love to see magicians and illusionists. We actually like to be deceived, okay? It's fun. It's entertaining. Digitally altered music, okay? It's deceptive. It's not real. Photoshopping images. I guess we all Photoshop images. I know my photographic skills are so bad that I have to Photoshop them to make sure that I'm not doing a disservice to the person I'm taking the picture of. So there are also situations where deception is pervasive and, I guess, expected, such as in political discourse. Okay, I mean, we're fooled by our politicians all the time. I mean, we just expect it. It's just part of our life. Commercial advertising, you've always heard about, buyer beware. Personal relationships. Who hasn't been deceived in a personal relationship over time, right? So, but scientists are not in the business of deception. So embedded in a culture of deception and dishonesty, dishonest discourse, how do scientists, students, and staff learn to pursue and administer science in a responsible and ethical fashion? So if you're Plato, you would argue that idealistically such knowledge should come within through introspection and reflection. However, if you are Aristotle, you would argue that would argue more realistic and argue that ethical behavior must be learned through observation, interaction, practice, and reflection. So this painting comes from the School of Athens by Raffaello, and it's in the Vatican Museum. If ever you get a chance, just don't ever miss seeing this. It's just absolutely spectacular. Okay. Education promotes professionalism, and it's the foundation for the public's trust in the research enterprise. So promoting professionalism and research ethics requires, in the educational process, requires a knowledge base, okay, to be obtained. It requires understanding of the basic ethical concepts, and of course requires introspection and reflection. But research ethics is applied ethics. Okay? Research ethics is applied ethics, and ethical behavior requires instruction in ethical decision-making, decision-making skills, and lots of practice. So the first hypothesis that we have that we're working with is that ethics education must reach all members of the research team to be effective, not just the PI. Research ethics education without good team ethical decision-making skills, the integrity of the research enterprise is at risk. And finally, education opportunities should be applied early in the scientist's development, often and in many different formats. So now I'm going to show you a little bit of just some data from the CITI satisfaction survey. So we ask, I believe, we provided this statement. I believe it is very important that the entire research team, PI, investigators, staff, students, and administrators, and not just the PI, should have a clear understanding of the responsible conduct of research. And so this is the data. It seems pretty clear that the vast majority of 87% think that it's fairly important that everyone on the team have the educational opportunity and the opportunity to understand what it is they're doing. So I want to switch and talk just a little bit about misconduct and the effect of misconduct in the research enterprise. The U.S. federal government has defined research misconduct as fabrication, falsification, and plagiarism, or FFP. Right? So it's either fabricating data, it's making up data, it's cooking data, it's changing data to be more favorable to your hypothesis and your particular bias, or it's plagiarism, which is basically stealing other people's thoughts and words and pictures and potentially music. Right? So the ORI reports, however, that research misconduct occurs relatively infrequently, and research misconduct is reported to ORI about 8 or 10 or 12 cases a year. And you can see these reports on their website. But it's really likely that misconduct is underreported. It's laborious and time-consuming to confirm research misconduct at a university. And it's very expensive to conduct a misconduct investigation. And so as a consequence, it's probably dealt with at an institutional level and infrequently reported to the ORI, Office of Research Integrity. So this is just to show how things are changing over the years. This is some data from Van Noorden, which indicates that over the past 10 years, the number of retraction notices has gone up about tenfold, even as the literature has expanded only about 40%. Okay? So people are retracting their hastily published works. Journal article retractions have been increasing as NIH funding has become more competitive. And this is data from a paper by James Hicks, which you can see that as the NIH success rate percentage, in other words, the percent of funded NIH grants decreases as a consequence of lowering funding scores and increased competition. The number of retractions in published papers has increased considerably, markedly. A paper in the PNAS in 2012 by Fang et al. Indicated that 67% of the a little over 2,000 retracted biomedical and life science papers that they reviewed could be attributed to misconduct. 67%. So what does this mean? It means that people out there are taking risks with their work, with their research. There's a push to publish. Probably many of these papers were published too soon. Or maybe it's just the science is bad. Maybe it's just the science is bad. How many scientists fabricate and falsify the research? Is this a real problem? A systematic review and a meta-analysis of the survey data was conducted by Fanelli. This was in 2009. In this survey, he found that only about 2% of the people who were surveyed would self-identify as having committed fabrication, falsification, or plagiarism. But up to about, 34% admitted to other questionable research practices. Right? So now when these same people were asked about their colleagues, okay, I don't do anything, but my colleagues do. About 14% responded to knowing that their colleagues had engaged in fabrication or falsification, and up to 72% they claimed that knew that their colleagues had practiced questionable research practices. Misconduct was reported more frequently in biomedical researchers than others. What is this questionable research practices? What is this? Right? Should we be concerned about this? So, for example, questionable research practices would be keeping inadequate research records, not keeping the notebook up to date, unmerited authorship credits, guest authorships, things like this, failing to disclose conflicts of interest. You know, conflicts of interest are really a big deal nowadays, and the government has come down very hard on making sure that people understand their obligations with respect to disclosing conflicts of interest. Duplicate publications, refusal to share research materials or data, using inappropriate statistical methods. So these are examples of questionable research practices. Misrepresenting speculation as fact, okay, hyping the data basically. Poor supervision of research subordinates and students. We hear about this more often. breaking confidentiality in reviews. And I would just as an aside say that in one of the research studies that we did with people who completed the CITI course, we asked them, we asked both the faculty member and the student how often the review of papers and grant applications were provided to the student. So how often the faculty member shared the review responsibilities with graduate students. And the response was flabbergasting. Almost 70% of responders, both on the student side and on the faculty side, said that they routinely share the review responsibilities with their graduate students, in direct, opposition to what the journals are expecting, most journals. So what's the big deal? Right? True misconduct, fabrication and falsification and plagiarism, is really a rare event, and you may have heard this phrase before, and I see it in print and I hear it at my university. Well, science is self-correcting. Eventually the correct data will be published and the scientific record corrected, the corpus of science corrected. So, but misconduct is incredibly costly to the institution. Right? It's incredibly costly. Students of people who are involved in misconduct cases, they suffer the most. Okay, their careers are jeopardized. I would refer you to a paper in Science magazine it was 2010, October of 2010, about a laboratory at the University of Wisconsin where the PI was accused of plagiarism by her students, and was effectively, she was dismissed from the university, and the students were just left floundering. And only one of the 7 students and postdocs that were in this particular laboratory finished out their training. Okay? Very devastating to students. Wasted resources. Okay, misconduct results in wasted resources. In many cases, their grants have to be returned. Millions of dollars at stake. Investigations are extremely costly. Okay? The average is about $500,000 per case. And then the loss of subsequent grant support from that particular investigator who has already, shown that they could be successful, and the result of the consequence of debarment by the ORI. Institutional embarrassment in the community is also a consequence. Loss of the public's trust in the clinical research enterprise. And again, there's also adverse societal changes. Right? Adverse societal changes. And here's a really good example. Okay, here's the poster child for misconduct and effects in the community and to society. This is Andrew Wakefield. Andrew Wakefield was involved in the publication of this paper in the Lancet, Ileolymphoid nodular hyperplasia, nonspecific colitis, and pervasive developmental disorders in children. This is the guy who made the connection between the MMR, the measles, mumps, rubella vaccine, and autism. Okay? Everybody knows this story, right? And really, this really changed the way the public thought about whether they should have their children vaccinated or not. Okay? So, but it turned out that this was all a fraud because Wakefield had an arrangement with a lawyer and had an interest in suing the manufacturers of the vaccine. So he changed the data, he manipulated his data to support this fraud that he was going to perpetrate on the manufacturers of the vaccine. Right? And so he was eventually found out and drummed out of medicine. But he's a physician. I think he's here in the United States someplace practicing. I don't know, Dan, you may know.
He lost his MD here.
Yeah.
Practice here.
Yeah.
I think he's back in, but I think he still maintained his licensure in England, didn't he?
So So anyway, what the result was is parents decided not to vaccinate their children. And of course what happened was that there was major outbreaks of measles, mumps, and rubella throughout the world. In the latest being an outbreak in California, also 30 or more hotspots in Australia. So there's real consequence. There could be real consequence of scientific misconduct, research misconduct. That can affect millions of people. I don't know if there were any deaths that resulted from Wakefield frauds, but certainly in other studies, there have been deaths associated with misconduct. And there was a study at the University of Pennsylvania, a researcher named James Wilson was doing a gene therapy trial. The trial had to do with the transfer of a gene for ornithine transcarbamylase deficiency. It's a single gene responsible for the disease, and Wilson was doing a study to determine whether patients that had this disease, people who had this disease, could be rendered cured, if you will, with a gene transfer. A teenage boy with OTC deficiency wanted to participate, but he wasn't eligible for this trial, okay, because he had a mild case of the disease and it wasn't severe enough to warrant to be part of the inclusion, to meet the inclusion criteria for this particular study. But the subject was willing and really wanted to participate anyway, and so Wilson decided that it was okay to admit him to the control arm of the study. Besides, the recruitment to the trial was down, and Wilson actually owned the company that was making the vaccine. So he needed to get things going. So you probably remember this. You remember the Gelsinger case, okay? This was really a very high-profile case at the end of the 1990s. Gelsinger was an 18-year-old boy. He was treated with the adenovirus vector. He had an allergic reaction and died within a couple of days. The concerns, there were concerns raised, regarding Wilson's financial conflicts of interest in the particular study, poor data safety monitoring procedures, and incomplete informed consent. It turned out that prior to Gelsinger being administered the vector, that someone else had a near-death experience on this particular trial. And also that there were a number of non-human primates that had been used in the preclinical studies that had died from anaphylaxis. So of course there was a huge media reaction. There was institutional embarrassment, lawsuits, ultimately a financial settlement with Gelsinger's family. But this is just a very heartbreaking case of the abuse of the public's trust. And the therapy, or the trial, was shut down. Wilson's research was shut down, and the institute, the gene transfer, the gene therapy institute at UPenn was also shut down. Of course, the case became politicized. Regulations were developed. And this was the beginning of CITI. Because in 2000, then DHHS Director Donna Shalala announced a new regulation that anyone who was funded by the government through the NIH in studies that included human subjects, that they must have didactic training in how to protect human subjects from research risks. And so this is when my colleagues and I decided that the only way that we could bring our institution, Shalala gave us 4 months to get this done, from June until October. And so we decided that the only way to do this was not with marathon face-to-face conferences, but with a web-based program. And that's where CITI began. Okay, so this is a picture of entitled "The Integrity of Saint Eligius." Saint Eligius is the patron saint of goldsmiths and metallurgists. I included this just to remind me that we should also be very concerned, as St. Eligius would be, very concerned about the quality of the research that we're funding, that we're promoting. So there seems to be increasing concern that much of the current literature, the current published biomedical research findings are not correct. Is sloppy science and non-reproducible science a greater threat to the research enterprise than misconduct? Is doing sloppy science misconduct? What can be done to enhance the reproducibility of our scientific endeavors? So I'm going to try to provide some insight to this. So this is a paper, there was a paper published by Ioannidis in 2005 with the title, "Why Most Published Research Findings Are False." This is the most widely downloaded paper from the internet. Okay, over 1 million downloads of this particular paper. He is a mathematician, and he took a purely mathematical approach to this issue. And he developed simulations to show that for most study designs and settings, it is more likely for a research claim to be false than true. Many reported studies are poorly designed, he concluded, and biased towards a positive result. In other words, the scientist was setting up the experiment to succeed rather than to be than an honest attempt to test the hypothesis. Too many variables are being measured in most studies. So the more variables that you're studying, the greater the chances that you're going to make a mistake or there's going to be an error. So he argues that studies should be, the number of variables and number of questions being asked in a study should be reduced. Statistical analysis inappropriate to the procedures or to the nature of the data. Data that's overinterpreted toward the personal bias of the investigator. And he also made the point that that claimed research findings may often simply be accurate measures of a prevailing bias, right? For prevailing bias. Science Magazine recently has begun an initiative, as announced by their editor-in-chief in January of this year, a new initiative to improve the reproducibility of science, and at least to start in the preclinical studies. So she's proposing to use the U.S. National Institute of Neurological Disorders and Stroke guidelines for transparency of data collection and reporting, and in so doing, the science will ask the authors from now on, or from January 17th on anyway, whether there was a pre-experimental plan for data handling, such as how to deal with outliers, whether they conducted a sample size estimation to ensure a sufficient signal-to-noise ratio, power analysis essentially, right? Whether samples were treated randomly, and whether the experimenter was blinded to the conduct of the experiment. Seems like these are things that we learned in Conducting Science 101, when I was a graduate student, but evidently it's been lost along the way. Now, on the other hand, while there's some concern about non-reproducible science, the psychologist discipline has taken a lot of criticism lately about how they conduct their science. And so in Nature, in November, in Nature, there was a report from a group, 36 international research groups formed the Many Labs replication project. Right? Not reproduction project, as I almost said, but replication project. Right? They tested 13 published and highly cited psychological experiments. They found that 10 of the 13, about 75%, were consistently replicated by the group. That's great. It's really good. Okay? Okay. The results were unaffected by the nationality of the volunteers or the setting of the experiment, whether it was an online experiment or whether it was conducted in a laboratory. So I think that's very good, but there are other data out there to suggest that that it may have been simply the experiments that they chose to replicate, and that others are not as easily replicated. So the NIH is mulling over rules for validating key results. And again, this is from a fairly recent paper, a Nature paper in July, where the NIH may require experimental validation for preclinical studies that could then lead on to clinical trials. The NIH may enlist independent labs for verification. Sounds like an expensive kind of endeavor, doesn't it? And it really does. So there needs to be higher, the NIH is suggesting there needs to be higher standards for animal studies. Okay? We need to be able to reduce the bias in animal studies. And having conducted many animal studies in cancer therapeutics, there is a tremendous amount of bias. It's all about the model that you use. It's all about the tumor that you use. You know, some hypotheses will be borne out depending on which tumor system that you use.
Quick question. The higher standards for animal studies, do you mean in comparison to human studies or to
No,
studies?
to the current standards.
Okay.
The current standards. That's the way I interpret it. Yeah. So there needs to, the NIH is suggesting new steps in peer review process could include greater scrutiny of the preclinical data, external validation of the results of, and tie the result of the external validation to continued funding. Private foundations. There's a private foundation in Texas, and I believe it's in Dallas, that is willing to provide funding for validation studies. The NIH plans to enhance reproducibility. This again is a paper just a couple of weeks ago in Nature by Francis Collins and Larry Tabak. They are proposing that the NIH develop training or a training mandate on enhancing reproducibility, on the emphasis of emphasizing good experimental design. And this would become part of the RCR training mandate that already exists. There would be more systematic grant reviews, more rigorous review of the scientific premise of the proposal and the published work that supports that premise. Right? So a clear mandate for more rigor in the review process. Greater transparency of data used in publications. There is now a website called PubMed Commons where you can go and discuss with your colleagues published articles, the merits or dismerits or demerits of published articles. Collins and Tabak indicated that there's also a community responsibility here, that stakeholders in the scientific enterprise to modify their policies to promote transparency and public trust. Journals will implement new policies to enhance transparency, like I mentioned in Science magazine. academic incentive system rewards for quick publication in high-profile journals. But yeah, I mean, maybe this is counterproductive, right? Maybe this is counterproductive. The speed, the rush to publish, right? And in some way, the NIH needs to change the culture and change the thought process of the P&T committees that are looking for rapid publications, lots of publications per year, and in high-impact journals. NIH should probably support productive sciences for scientists for longer than the 3 or 4 year period that current R01 grants extend to. Anonymizing the peer review system was also suggested as a way to reduce bias. So, but even industry is having problems with reproducibility in their science. In September of 2011, the Bayer Health Care finds inconsistencies between their in-house and published data in almost 2/3 of their projects. Now that's pretty scary. Amgen, a publication shows that findings from only about 11% of 53 landmark papers can be replicated by their company scientists. And in January of this past year, the chief executive of Science Exchange asked more than 22,000 study authors if they would want her company to arrange verification, free verification of their experiments. Excuse me. Nearly 2,000 said yeah. In May of 2000, a survey at MD Anderson Cancer Center finds that more than half of its respondents have tried and failed to reproduce published data. This is a pretty sorry state. Right? In fact, it's very depressing. So, is sloppy science, non-reproducible science, a greater threat to the research enterprise than misconduct? Well, you be the judge. I mean, I don't think all the data's in. We don't know what the real cost of sloppy science or non-reproducible science is, and we don't know what the consequence. And we don't know what happens to people who get caught up in that. Is sloppy science misconduct? Well, no, not in the United States. Okay, in the United States, it's only fabrication, falsification, and plagiarism. In Europe, conduct that violates the accepted norms is misconduct. So sloppy science would violate the accepted norms and be considered misconduct. Sloppy science is unnecessary, it's risky, and it's unethical. So what can be done to increase reproducible science? Well, the CTSI, and this is really the crux of the message here, the CTSIs can initiate programs and engage the community of investigators to increase the public's trust through enhancing reproducible science. What will be the added value? Well, research ethics education and training is fundamental and a value added. You know, basic research ethics education includes such things as basic courses in human subject protection, good clinical practice, the responsible conduct of research, lab animal welfare, and the like. It's important for the institution to take a programmatic approach. There's no an institution should not rely on a single program like CITI, for example, to provide all of the training necessary to ensure that their employees, their faculty, their staff, and students are going to behave ethically. There should be multiple opportunities for research ethics education. It should come in different flavors, different types, different modalities, and at multiple levels, and it should be discipline specific. Right? So it's the people who are conducting social behavioral research. They don't want to read about. They don't want to be involved in ethics training that has to do with biomedical research. It just doesn't play. And we're a living example of how that doesn't play. Mentoring. I mean, I could talk for an hour about mentoring and how important mentoring is, and clearly the CTSA can go a long way to enhance the professionalism in science by engaging responsible faculty members to mentor younger investigators and graduate students. Interestingly, the data that comes out of our satisfaction courses indicate that most students, somewhere around 70–75% of students, tell us that their research advisor and their mentor are the same person. Now that is a very risky situation, because what is the student to do if he has problems with his major advisor, with his research advisor, if he doesn't have a mentor, right? So I think the CTSA can go a long way to transforming that situation. Opportunities for research ethics education should be provided to the entire research team. And advanced courses in bioethics, biostatistics, research study design, good laboratory practice, courses for clinical research coordinators, CRCs, should be one of the things that the CTSI does to enhance the infrastructure through certificate courses, master's courses, and the like. Program accreditation is one way to enhance the professionalism of everyone at the institution. Professional certification for individuals. The CTSI is the perfect vehicle to deliver the tenets of ethical conduct of research practices throughout the medical center and the university. Delivery takes funding, and to do more than just the minimum, and it's, I think, risky to the enterprise if the efforts are minimalist, as the target audience will quickly interpret the minimal effort as having minimal import. The ethics component of the CTSA can be the universal donor, okay? And you can purposely weave into the fabric of all, be woven into the fabric of all of the CTSI components. Funding discipline by the leaders of the CTSA to make sure that the ethics components receive the appropriate funding is critical and very important. The CTSI leadership is committed to transforming the Med Center to expedite the translation of cutting-edge science from the bench to the bedside. We all recognize this, and it's why we're here. But we must be committed to ensure that all researchers at the university conduct their research responsibly, and we should promote awareness and understanding by all members of the research team that shortcuts that violate the responsible conduct of research are unacceptable. In expediting research of findings from the bench to the bedside, we all need to be concerned that the speedy translation doesn't come at the cost of high quality in the conducted research. So I have like 2 minutes. I just wanted to share with you. This is one of my favorite paintings by Joseph Wright. Has anybody seen this painting before? Okay. This is Joseph Wright was a painter who was very interested in how technology of the day influenced society. Okay, so this is a painting whereby it's entitled "An Experiment on a Bird in an Air Pump." Okay, really a vacuum pump, right? So this is a traveling scientist who would come to the home of, say, a wealthy patron and put on demonstrations, science demonstrations for friends of the family, members of the family, the children of the family. Okay? And so here's the scientist, here's the bird. You can see the bird in the bell jar. Okay, and the scientist is taking the vacuum, pulling the vacuum, reducing the air, and the bird looks like it's in, close to the death throes. Okay, so this particular painting, while we may think that we're celebrating the invention of the vacuum pump, really what what Joseph Wright was trying to do here was to focus our attention on the other people and how the other people in the painting were interpreting and experiencing what was going on here. Well, first of all, you can see that there are these young people, okay, maybe family members, okay, that are just mesmerized by what's going on here, okay? This is not unlike what's happening in modern day science, right? There are people who are just infatuated with what's going on from a technological standpoint. Here are two people invited to the home, potentially young lovers. They could care less about it. They're all wrapped up in each other. Okay? They could care less what's going on. Right? Here's the dad over here. I presume this is the dad. These are young children. She's so distraught at the thought of the bird dying that she can't even look at it. Right? Both of them are obviously very upset about what's happening, and they fear that the bird is indeed going to die. But one of the most interesting characters in this painting is this guy here. He's the philosopher. He's sitting there and he's wondering about what all this means, and how can he rationalize all of this, the technology and what's happening to what is 18th century London. So it's interesting. Well, the other thing that's interesting is that this guy here looks like Isaac Newton, right? It's a remarkable similarity. And of course, this is Joseph Wright. And I think I am like 1 minute over, and I apologize for going over. But thank you very much for your attention. And it's a pleasure for me to be here.
Do we have to exit quickly, or do we
Yeah,
have
they're
to
taking a quiz, but we can go back to our conference room if anyone wants to meet.
So can we take a minute of questions, or do we have to leave right away?
One question?
One question.
Anyone have a question?
I sincerely appreciated the presentation, the opportunity to hear it. I was curious as to whether you felt the private industry versus the government talk about reproducibility with $1 billion at stake, according to the pharmaceuticals, of having the human development drug. Does the private side have it more right than the public, or vice versa? And so, has anybody explored the elements associated with the lack of probability? How much have you delved into this?
You mean the lack of problems on the private side?
Yeah, it seems like maybe there are fewer problems. It looks like the Asian example, which I read about also, because it seemed like that was kind of persecuting what's been done on the public side, and with the laboratory guys on the private side.
All right. Well, I don't know. That's hard to say. I think that, first of all, the pharmaceutical industry has had incredible failures in phase 3 trials throughout the world. And so why is that? I mean, is it that all the preclinical data was pointing them in the wrong direction? I don't know. It's hard. It's really hard to. Oh, I don't know that we know that. No. I don't think we know that. And it'll be hard until there's some kind of public disclosure of industry data, and we have the opportunity to actually go look at it, and we won't know. We know in the past that the pharmaceutical industries have tended to hide their data, and we know that the pharmaceutical industry is much more likely to publish positive results than negative results. Okay, it's clear. I mean, it's like 4 to 1, in terms of that type of publication. So I don't think I can really answer that question, but it's probably not.
Thank you again.
Thank you very much.